I've been known to be clumsy, so it wouldn't be good. But one of my kids would probably do that though. Anyway, if anyone else, welcome to Thursday's class. If anyone has words of encouragement, we could start with that. Hi, Dawn. I see you now. I'll write you down. Let's also think about today. I stopped. Well, sometimes I do the prayer before class too with the words of encouragement, but I explained to everybody in the beginning that I stopped. I'm not against it though. So today, instead of a prayer, I think we could just take a few breaths and a few deep breaths and close your eyes if you can. And think about, send some positive thoughts or prayers to anyone who's sick or grieving, troubled, addicted, and then definitely to anyone who's sun dancing in this heat or working outside. Also, it's different. That's not as spiritual, of course, but it's also pretty hot for that. So I'm going to take 3 breaths and think about that. So you guys do your own prayer in your own head if you want. Also for people traveling, so many people travel in the summer and it's so expensive this year. Oof. And then if you don't have much money and you don't have a car that works very well and it breaks down in the heat, oh, how many times that has happened to me. So that's really tough too. I was even just thinking about that yesterday. I shouldn't let it cross my mind because my main car has 360,000 miles on it and it's still great. But I was just driving to town 2 days ago and I was thinking, gee, if this breaks down right now, I'm not gonna have the money to fix it for a couple of weeks. And that is not a good feeling, you know? So anyway, in the heat, I always think about it because we used to always break down in the heat. Oh, I'd be like pregnant. I was pregnant one summer in South Carolina, big and pregnant, 7 months pregnant. On the way to the midwife, I'd break down like every other time. And I had 2 other little kids. And we'd just be like walking on the side of the road in a rural South Carolina, hoping somebody would help us because no cell phones yet, you know. Sounds like unbelievable now, but well, even now down there, I was there last fall and there's still a lot of places with no cell coverage. So it's almost like the old days anyway. All right, no one else sent words of encouragement, but that's okay because we did our positive thoughts to people. And remember that I don't know if any of you get anxiety or worried, but taking 3 or 4 really good deep breaths and slowing it down is really good for us. So it's a good thing to do for our mood too, and for our lungs, obviously. I never did any deep breathing until I was a cigarette smoker, and then when you inhale, and that's when I realized, oh, I could be breathing deeper than I normally do. But that's not the best way to do deep breathing with a cigarette. But I'm not judging because I loved it. I had to quit though. Anyway, I want to go over 2 sections today. There's a little bit out of order, but they'll go really well together. And it won't be overwhelming or anything. It won't take more than 2 hours, probably less. But I heard from a couple people. I got most of the quizzes, and I still am organizing those to get the grades posted. So you'll hear back from me about your quiz grade probably by tonight. And if anyone didn't get to theirs, just talk to me. And if you have homework questions, so the homework due today was the 3-4 and 3-6. Let me think. That was chapter 3, part C. That homework on WebAssign. So that's what was due today. Did anyone have a question from that homework? Or if you want to meet privately with me after class or on the break, we can go over things individually too. We always can do that. Or meet in the evening or tomorrow morning privately on Zoom. Did anyone have trouble with plotting the inequalities on those number lines? Did it give you headaches? I hope not. You always can send me a message through WebAssign too, if that's ever happening, right? When you're on a certain problem. Some of you have done that already. Like, hey, what's going on? Why is it doing this to me? Then I'll heads up. I already have gone in and done the override for a couple people whose WebAssign glitched on them. So I just fixed their points in there. Okay, Tommy, no hurry. I'll just start the lesson with formulas. I'll start 3-5, and it's pretty short because we don't do all the topics in this section. Let me make sure I have my recording on. I do. This is our second to last day of class before the final. I already have I have 2, maybe 3 people that are going to take the final Sunday night at 6. That's an important announcement. If you would like to do that and get it done with, you're welcome. It'll be our usual Zoom link, and I'll send a reminder on Sunday. But I'm sorry that's the only time I can do because I forgot that I had signed up to work at our food co-op. So, oh well. And then we also can do thanks, Eileen. Gotcha. Sunday test. Oh yeah, Tommy, I'm sorry. I always forget about Eagle Butte. I mean, I don't forget about Eagle Butte, but I forget that they're in a different time zone. Yep, mountain time. 6 o'clock mountain time. I don't think it'll take anybody the full 3 hours. It's about half the length of the midterm. Just because if you see, like the midterm was after we're at 2/3 through the semester, and then the final is just the last 1/3. Yeah. So if anyone wants to do that, you can. If not, don't feel pressured because I'll still be here on Monday at 1:45 to proctor the final on Monday. So anybody who can't, I mean, Monday's our normal class time, obviously. So that's fine. So no pressure. I just thought, oh, there might be some people like my last summer class, some of them had day jobs that they were having to take time off of for the class. And that's rough, I know. So this would get us around that, or kids, children to watch, or lakes to visit. But no, lakes are kind of quieter on the weekdays. I went to the state park for a walk one day, and one day during this week, and it was so quiet, but the weekend is very busy. Okay, Tommy, that'll be fine. I'll leave time for anyone to go into breakout rooms and ask individual questions today, okay? I promise. I promise. Because it's not, you'll see, it's not that intense of a lesson today, I don't think. Oh, that's exciting, Kristen. How old is he? Double digits. Nice. Love it. I loved turning 10. One of my daughters, my older daughter, it was so strange. I thought I had never seen anything like it, but she when she wanted to wake up early on her birthday when she turned 10, and then she just cried and cried that she was getting old. I was like, but you're getting old. Like, a lot of kids are excited to get older. You know, more privileges, bigger, catch up to their big brothers. Exactly. Well, that daughter, she's so cute and sweet. That daughter of mine, of course, I would think so. Oh, you cried when you turned 30. That's funny, Kristen. Oh, Hannah, oh, you did too, huh? I wasn't laughing at you. I was laughing at what Kristen said, but oh, that's okay, Valerie. I got you written down here. No worries. We're just starting out slow. Just take a moment, take a few breaths. If you're just joining us later, take a few breaths and send some positive thoughts to people who are either sun dancing or out in the heat for other reasons, or sick or sad or road tripping in a bad car. So anyway, just take a little moment. I'm starting kind of slow today. So 3-5 is formulas, and they're like useful formulas. The ones that we'll mostly work on are distance equals rate times time. We do interest. Simple interest is principal times rate times time. We'll do a few examples of each. We do some geometry ones like area, perimeter, and volume. Let me think. If we do circles too, sure, we do a circumference of a circle. And I have an interesting story when we get to those ones about she's my friend, massage therapist, and karate student. So that's an interesting relationship, huh? And younger than me. But she had a crisis with her Intex swimming pool, her kiddie pool. And I was going to tell you guys about it. Not to make fun of her, but just to show how it's useful. We already did work rate problems, and those won't be in the final. And we'll do a ticket sales problem, but we've done one of those before too. Ticket sales and an IV drip. So let's say rate of, I'll just write a drip, but it could be a rate of anything. We've done something like that before. Yeah, I teach Tai Chi and karate and kickboxing. Usually, I got too busy during this summer, so I stopped for a while. So I took a little break, but I'll probably at least go back to teaching Tai Chi in the fall. That's free. I teach that at the college centers too. I used to teach kickboxing sometimes at the college centers also, so maybe we'll get to do that again. I've done it online also. It's not quite the same, but anyway, let me just make sure we did. Yeah, that's so. Rate of a drip or a pool emptying, etc. So that's it. So this section, if you have the book, you'll see that it also talks about work rate problems and mixture problems, and we don't cover those in this section. I mean, if we had a lot of extra time and we were really interested, we would, but no need. It's summer and it's not going to be on the final. And if anyone's interested, I could assign some of those for you to play with. Ages. Let me think. What ages have I taught karate? 4 to, I think that one is 45. Oh no, but the other one, 55. That's what I've taught so far, but I've also taught a lot older people in the past. Not usually younger in karate, just because you don't want to scare them, So little kid karate is just mostly fun, and you teach them how to not get in fights, like how to be confident enough that you aren't like bullying around on the schoolyard. I'm getting a couple messages, so. There we go. All right. So the formulas are really useful. So we'll start with the easiest one. Why not? So distance, and it's nice in this online environment, isn't it? Because you don't have to memorize. Distance equals rate times time. We also could write it differently. Like you could get rate alone and say this is the same formula in different different variations of it. Rate equals distance over time, or time equals distance over rate. And most people that I know, especially out here where people drive long distances, do this naturally, like just in their head. And I don't believe in memorizing formulas, so it's great that we don't have to right now anyway, because your final will be open book and everything. But I believe in like learning why the formula works that way and like the basics of it. You'll see what I mean when I show the area problem. But once you know like the foundations of it and why that formula even exists, then it's easy to just figure things out, like remember the formula that way, like not by memorizing, but by understanding the fundamentals of it, its essence. So that, I don't know if that makes sense to you or not, but that's you'll hear about that again if you ever take another class from me, because I'm always like, no, I don't believe in just memorizing a million formulas. Okay, so let's say if one example is I drove, and just speak up if you have certain questions about these or anything. I drove 800 miles. I love to go on long road trips if gas isn't expensive. So let's say I drove 800 miles and it took 14 hours. Oh, hi, Carrie. Great. Let me write you down. How fast was I driving? So when we ask these questions in these classes, right? Of course, you wouldn't have been going exactly the same speed the whole way to wherever. If you're going, this would be like to Omaha or something. You can't, you stop to go to the bathroom, you stop to fuel up, you slow down if there's traffic, speed up if you think no one's going to catch you. Like if you have car trouble, you slow down, like, or you have a kid that has to go stop at the side of the road and be sick, all those things, right? So you don't just go a constant speed, but that's what these are asking. So we're going to find the average speed. That's what the number that we'll end up with is going to be our average speed. I've just made this up too because it never has taken me that long to go 800 miles, but I just thought it'd be fun to make up a different one. So figure that out if you want to. You use whichever version of the formula works for you, and we'll do another one. Round it to the whole number, because I didn't tell you what to do, how to round it. Good job, Valerie. Give you some points here. Who just said they're here? Oh, Carrie, right? Did we have everybody here today? 6, 8. We got everybody. Yay! Extra 3 points, extra credit for everyone for all being here. Writing it down. Yep, Kristen, you're right too. Good. So like I was saying, I also used to have a reputation of being a really chronic speeder. And so I never would have gone that slow unless I was, but I did buy a little tiny Chevy Spark used a couple years ago. So the rate is going to be 57 miles per hour. It turns out to be like 57.01 or something, but let's just call it that. 57 miles per hour was my speed, which is the same as the rate or rate. My little Chevy Spark I bought during the pandemic to drive to New Jersey because I was afraid to fly. I didn't want to get my parents sick. And that little thing, it's an itty bitty. I don't know if anybody's ever seen those. They're like, I think a V6 maybe. And they can't go very fast. Like if I go above 55, it goes like, makes all this noise. So I'm on the interstate, like with it making that noise and chugging along. And so I did actually drive to New Jersey kind of slowly, more slowly than usual. 2 years ago. So, because somebody just asked me, it's safer to be a turtle driver. Be proud of that. Let's do another one on this page. So I did one where we knew the distance and the hours. Let's do one where, let's say I had some issues with someone. Let's say I had an argument with someone and I just drove flat out 50 miles per hour for 2 hours. How far did I go? So that's what these are like. You'll know one of them. So in this one, I know the rate. I know the time. Good job. Yep. And then I'll end up with the distance in miles. Oh, let me show you that too. Officially, we're like this: 50 miles per hour times 2 hours. Hardly anybody does these this way. You don't have to, but this is what's going on. Times 2 hours equals 100 over 1. So that I'll cancel off. But see, the hours cancel and you're left with your label. So if you do it this kind of railroad track way that you might have learned, they do it in middle school in the first times for most schools, I mean. So you might have learned it that way. That's a good one for unit conversions just to get used to it if you want to set them up that way, but it's not required. But that's what's going on, because sometimes people are like, well, how did you know what label to put? And so that helps if you first of all set up a problem that has a formula, pick your formula, then kind of insert them by the things that they are, like the rate and the time. And then it kind of helps to line it out. Some people, like I've said before, I work on the Lakota values because I love them, even though I'm not a Lakota person, but I work on those. I think they're very important. But my hardest one is patience. And what I do is just dive into a problem and start crunching the numbers without slow my roll, make sure I understood it. So sometimes I'll dive in and miss something and make a mistake. I have to pull out or get frustrated. So that's me. Like everybody knows themselves. So if you're impatient like me, you'll be like, no, I don't want to do all that setting up. I don't want to do all this stuff. I just know it's 100 miles. And that's fine with me. I don't care. I'm not going to ask to see all that on your final. And as you get more advanced, I'll need to see more work showing, and you'll be in face-to-face classes probably, and you'll get more practice with that. So don't worried. Any question about that formula? That's our wonderful, easiest one, huh? Next one is simple interest, which is pretty easy also. And people usually have seen this before, like in business math. Interest equals the principal times the rate times the time. The time is in years for this formula to work. The principal is your starting amount. And simple interest isn't really realistic anymore. It's not, doesn't really show up hardly anywhere. Usually it's compound interest or instantaneous compound interest and things like that. But we do more of that in, we work on those in Math 134 and 154. So P is a startup amount, whether it's an investment or a loan. R is the rate, the interest rate as a decimal. So they'll give it to you as a percent, change it to a decimal. And T is time in years. So there's our variables. The I is the amount of interest earned, interest that you either earned or paid, if it's a loan, earned or paid. So it's on top of your initial investment, or it's on top of what you're paying back. So if I got a car loan using simple interest, the P would be the loan amount. The rate is the interest rate. The time is how long to pay it off. And the I would be that extra interest that I had to pay on top of the original amount that I borrowed, like that. But we'll look at it, the first one as an investment. So let's go. I'll just write it up here on the top, PRT. And we'll do two of these. I invested, I'm making this up because I don't have any simple interest accounts right now, or that much money to invest right now. But anyway, let's pretend I invested $1,000 at a 7% rate, interest rate, and left it in there for 20 years. How much interest? We're going to find the I, just how much interest did I earn? So this is the easiest kind. If they give you the P, the R, and the T, here's the P. The R is going to be, change it to a decimal. This is in time, is in years, so that's T. Nice job. Someone already got it. And those of you who are whiz with finances and business and accounting, often I have students who've been doing the book work, acting like an accountant for a business or for the tribe for years. And then they're just coming back to make it official, right? With their degree and get a raise. That's good. So how much interest did this earn? So we take the 1,000 times 0.07 times 20. And honestly, what people have the most trouble with is, me too, is the decimal point placement. So if you do it by hand, just be careful with your decimal point. It's going to be $1,400 interest. Isn't that cool? That's not even that high of a rate. So that's more than the original amount that they invested. So altogether, I didn't ask this part because that's not really part of this chapter. Altogether, if I really stick with it, with that one, I'll have the original 1,000 plus 1,400 in the account after 20 years. So they're always saying that, like about retirement funds, any kind of investments, if you can leave them in there. And if they're not volatile, like the stock market, you just can never trust what's going to happen. But if they're steady and you just can keep it in there, it's to our benefit. However, me as a mom, a single mom, I've been in the past, I've been broke in the past, I moved a lot. There's a lot of times when I needed to pull money out of my retirement, for example, which was Isn't there always like, that's not very advised. It's not a good idea, but sometimes you have to. But if you can just leave it in there, that's great. Let's do. Does anyone have a question about this one? Let's do one more where we find the rate. And this is one of my favorites. Here it is. This is from the book. The interest that they earned, this is $54. The principal that they originally invested was $450. The time was 2 years. And you want to find the rate, the interest rate. I equals, some people call this the PERT, I equals PERT. There's shampoo called PERT. Maybe that's old, long ago. Good, Valerie. Yeah, it's good. I know most people have seen this, but using most of these formulas, it's still good. Super good. So this one's a little harder because the setup, just be careful with, and you're looking for a missing number, but you're going to get the decimal, and then you have to change it as to a percent. So you have one last step on this one. So I'll show the setup and line them out right where they're located in the formula. I take off the dollar signs. I'll tell you why too. There, then you're gonna try to find R. So like if these both had dollar signs, and say I divided both sides of my equation by the dollar sign, it would cancel off. It would be gone. So we don't have to write them if there's a dollar sign on both sides. I figure why clutter it up? Let's just keep it simple. So I'm gonna take it slow with this, a little slow with this one. So 900 R combining the 450 and the 2 equals 54. Divide both sides by 900. R equals 54 divided by 900. So that's 0.06, isn't it? Yep, 6%. So that's the interest rate. That's where, like in real life though, if you're gonna go make an investment or get a loan, you better know the interest rate. You don't throw your money down until they tell you like everything. And don't ever let them make you feel thick-headed either, because they'll do that. They'll do that at car lots, they'll do that at the bank, they'll do that somewhere where they want you to invest. They always try to make people think that they're not smart in math, but you always can get all the information on paper and take it home. You always can say, I have to go think about it. So I grew up in New Jersey where we were really pressured, high pressure sales, especially at car lots. And my dad would get all flustered. He's brilliant, but he just flustering it. Oh, that's fine. I'll just agree to it. Oh man, and I've seen students that do that too because they get flustered too, or they don't feel secure about the numbers or something. So what? You don't have to feel secure. Pretend you do, and then take it home. Then share it if you want to talk it over with someone who's done it a lot before, or look at it slowly, or even talk to one of your teachers like me. Oh, that's what we're here for. This makes my day. Oh yeah, let's do it. Somebody asked for another. So now, oh, but like I was saying, they would hardly ever in real life have a secret interest rate. Like, that's sort of silly, but let's do one more because I had a request. I'm just pulling these from the book, like I said, but their numbers are really funky in the book. Here we go. Let's say if your interest rate is, your actual interest earned is 97.30. Like I said, this is a book one, but sort of weird. The principal that they started out with was 1,200. The rate was 4.5%. That's a little more realistic. And they want to know how long was your investment in there for? How long was it in there? So find the T. So again, just get your what am I calling it? Like a template. Your formulas are like templates. And change that to a decimal. And then I'll be quiet and let you work through that one. Deck. Oh, hold on, I have a quick message here. Okay, see you, Tressa. That's fine. All right, so geometry, basic formulas. Area of a rectangle is length times width. Perimeter is add up all the sides of whatever shape it is. So don't even make a formula for that. You could just say add all sides. For this one, it would be, it's 2L plus 2W. That's the perimeter. But I don't even think that's necessary. Just remember, I'm adding up all the sides like fencing. Like I'm making fence, or I'm on a SWAT team and I'm securing the perimeter like that, right? An area of a triangle is really like half of a square or a rectangle, if you think about it that way. So it's 1/2 of the base times the height. Here's the base, and the height has to be straight up from the base. So the area of a triangle is really, it's the same as length times width, really, divided by 2. It's because it's only half. Like here, if I had those two triangles, then they'd each be half the area of the original thing. So these are all in the book on page 137. And if anyone needs me to post the formulas on our Moodle, I'm not sure if I have the formula page posted. I'll have to double check. But if you need the formulas because you don't have the hardcover book, that's fine. Oh yes, I'm getting to volume and circumference. So first let's do circumference of a circle. That's the distance around. Circum means to go all the way around, like circumcise, circumnavigate, circumvent. That always means make a circle around. So circumference is like the perimeter of a circle. So it helps to understand the words. And that's pi times the diameter. So pi, we use 3.14 in school, or you can use the pi button on your calculator. And then circle area is the whole, if you're going to paint the whole thing or fill it in with some nice tiles, although that's difficult. That's pi times the radius to the second. The radius is just halfway across the circle. Diameter was all the way across. And now for what we've all been waiting for, volume. So volume is 3 dimensions. So we could have a rectangular shape like a shoebox. And then the volume is going to be length times width times height. Or more fun to me is if you have a circle and then like a cylinder shape. So this is, say, let's put this back part the right way. Dot, dot, dot. Like those, you might see some water towers or elevators are this way, a circle, and then up. So you take the area, so any shape works for this, for volume. V is the area of the base times the height. So for a cylinder, a lot of packaging in the store is shaped like cylinders. You might have wondered why or ever think about that, but cylinder volume is the area of the circular base times the height. Pi r squared times h. And then your answer for area answer is always square whatevers. Square centimeters, square feet, square inches. And volume is going to be cubic whatevers. So it's like, how many little sugar cubes fit in it? That's what we're asking. How many cubes would stack in there if you could do that? So we'll practice a couple of these. So just think of that, little sugar cubes. I don't know if you can even buy sugar cubes anymore. In Africa, that's all we could get. I don't even know why. You could only get sugar in sugar cubes. It's really hard to bake. I'd have to mash them all if I was gonna. I'd make some things in my Dutch oven, like lemon squares and stuff, little things, brownies. Anyway, so those are our geometry formulas. So I'm getting distracting myself. Sorry about that. So let's do a few. So let's say find the area of this triangle. So here's the height is 4 inches and the base is 6 inches. So we can find the area of that. Let's do perimeter of a square. And each side is 3 centimeters. And we can do a circle and then we'll do a volume one. Let's say area of a circle. Let's do both, area and circumference of this circle. And all we know is that r equals 5 feet. It's a pretty big circle. That's almost like those ones out in the pivots. Those are much bigger. Pivots are bigger, but that's important one to figure out too. And then I'll put on the next page, I'll put the volume question and then come back. So let's say we want to find the volume of a pool that is 20 feet long, 10 feet deep, and 12 feet wide. So your answer is going to be, it's not water volume, it's going to be in cubic feet or feet. We could write that as feet to the third. So we'll do that one too. That's just, honestly, that's as tricky as they get. Oh no, there's one more where you have to find the depth. Oh, we can do one more after this, but let's go back to these. Then we'll take a break. So remember the area, some of the formulas that I talked that you need for these ones are triangle area is 1/2 base times height for a triangle. The perimeter is distance around. area is pi r squared, and circumference is pi times d. The reason that we do this, reviewing this, because this is things that you would have seen before, is because we start throwing algebra into it next semester. So we'll say, like, find the area of a triangle whose base is 2 feet longer than its height. Like that. That's like a basic kind of algebra one that'll start up. Or find the length of one side if you know the perimeter is 150 meters. That kind of thing. So we'll start having missing numbers, but right now we have all the numbers we need. We can just work those formulas. Send them to me if you want. I'm gonna, if you're working on that, that's great. If you're already on your break, no, I'm just kidding. So let's go back to this page. I'm gonna add one to this page. Another swimming pool problem. The swimming pool is the theme of the day. If the volume is 3,125 and the length is 50 meters, the length is 50 and the width is 25. This is supposed to be an Olympic pool, it says. Olympic. They're big, huh? It's nice to swim laps in those, huh? Almost like Evan's Plunge. I wonder if Evan's Plunge is that big. It's pretty big. Then they want us to find the depth. So that's a slightly harder one. But I know you can do it, because it's a lot like those principal ones that we did. Height in a swimming pool, the height is the H. The height would be the deep. The H is what you're looking for. So remember that. Always give yourself a moment. Like I was saying, I sometimes don't. Give yourself a moment to line it out, get it on paper, make a picture, even if you don't think you're an artist. Doesn't matter. Just get a visual there for yourself, and it'll probably help. This one, before I go back a screen, this one, number 4, you end up with a really big number of cubic feet. And most people, like cement delivery people, for example, use cubic yards instead. So you might wonder if, oh, can I just convert it to cubic yards? It's a little more complicated. It's kind of might do it after the break, but it's not required for this class, but you might just be thinking about those things. It's great if you are. All right, let's go. Let's go over these and then take our break. So the area of a triangle is the base times the height times a half. So that one's going to be 12 square inches. Be careful with your labels. Try to always have them on there. Because if you're in a business or construction or something, or even fixing a car, you need to know what tools to use. You need to know what size it is. If I just walked up to somebody and I said, I want my new deck to be 12. If I just said that, I want you to build me a deck that's 12. Like that, they'd be like, Jenny, 12 what? I'm like, anyway, $12 is what they'd say. This one, the perimeter is just centimeters because we just went around. So it's straight up centimeters. This one is going to be 25 pi. You can leave it like that usually, unless it says use 3.14 for pi. Then it would be 75 something or 76. And then diameter is 2 radii, so it's going to be 10 pi. Or 31.4 approximately. Does anyone have a question about those? And then look what I just did. I just did what I said. Don't ever do this. The area is square feet. Their circumference is plain old feet. And there are teachers that'll dig you hard for not putting labels. So I'm too much of a softie, I think, for sure. But even I'll take off a part, like at 0.2 of a point if I'm grading someone's paper and they don't have their labels. So it's good to have them. Okay, the volume of the pool. Hold on, Daisy, just a minute. Is length times width times depth. So see there, each feet. So that's why you end up with 24. Is it 2400? 200 times 12 cubic feet. That's why it's feet to the third, because there was 1, 2, 3 of them all had the foot label. And then this one is really going to be the depth is the volume divided by length times width. And that one's answer is 2.5. Oh, exciting. Just throwing things around up in here. So the depth is 2.5 meters. And a meter is a little more than 3 feet. So that's, 3 times 2.5 is 77.5 feet. So it would be almost 8 feet deep. So that would be that one. Does anyone have questions about those? So after the break, we'll do those two that I said we would do, the intravenous drip and the ticket sales problems. And then we'll explore functions a little bit. We don't get too extensive with the functions. It's the end of the chapter 4 topics. So tomorrow we'll do the rest of the graphing topics. I thought we'll just do functions today because they're kind of fun, I think. So anyway, 10 minutes, all right? 2:07, come back at 2:17, please. Talk to me if you need anything before then. Okay, this is the extra credit. It doesn't have to be, it's not a secret question because everyone was here, at least in the beginning. But if anyone wants to do this, you can. I should give it a little more credit. And my tablet started glitching up on me. So that's why I was kind of hesitating. And let's make this be 7 points because that's a little bit more work. So just, you can send that to me if you want, or think about it later. Already got an answer from someone. Good job. All right, let's go. Go on and have the recording on so anybody could look back on that. Or I have the whiteboard up too, so I can even look back. Let me see who that was from. Great. And I didn't ask any extra, like, would it hold the pool plus a couple of grown-ups and a patio chair? Like, no. And so I just left it at that, but it's really kind of fun. I think these are kind of fun to think about. Okay, for the people who are going into the health fields, let's do our intravenous drip. So the IV bag example always comes up. It used to always be on the final for this class. A 1000 milliliter bag, IV bag, is attached to a patient, and it's supposed to empty in 8 hours. I have a daughter who's a nurse, and she says it's true. Like, they have to learn all this math and stuff to get their RN and their degree, but there's so much computerization now, and you don't have to actually do the calculations in your head, but if you make a mistake, and she says this a lot, what if you push a button wrong, make a mistake, you could kill somebody? So it's a big deal. Anybody in the health field, whatever level you're at, it's very important. Even like a home health aide, I mean, from that to a brain surgeon, they're all very important, because just like daycare providers or in-home daycare providers, one of you does that, at least one of you, and look at how valuable that is. That's so important. Like, anytime you're dealing with life, you gotta just be really paying attention. So it's good to still know your math. So they'll ask, what's the rate of the solution flow? The rate of flow. So this is, you take the milliliters. It's a lot like unit price, actually. 1,000 milliliters divided by 8 hours, because we want to end up with milliliters per hour. Good job. Somebody got it already. Wonderful. Marvelous. And a couple other people got the swimming pool one too. Let me make sure I wrote you down. Yep. And one more. Good. Yep, good. And so these never, in our textbook or on your web assign or your homework, they never get trickier than that. They're not gonna ask if you know the milliliters per hour and the size of the bag, how long did it take? They don't even get that tricky. So this is as tricky as they get. So there's no need to show anything more dramatic. 125 milliliters per hour. Remember, a liter is about the size of a pop can, or two. Those are 2 liters. A pop bottle. I was thinking a liter is like a quart size. So a milliliter is 1,000th of a liter. So it's just itty bitty little drip. So just dripping. Any questions about that one? That's the label to that one. And I feel like we did this ticket problem. Why would I have done this already with you guys? Oh, well, we're gonna do it whether we've done it or not before. So ticket sales. Oh, you know what? Maybe we did it in the story problem chapter. So I'll write it down. Tickets sales totaled and I have one more that we'll do. $1,700. No, this is a good one. The number, this makes us do a tiny bit of algebra. Sold to adults, the number of tickets was 3 times the number sold to children. Then we need one more bit of information. Oh, two more. The prices of tickets for adults were $5. Kid tickets were $2. How many of each type were sold? So here we're venturing into a little bit of algebra. And now I'll go through the steps of this. And like I said, I want to put on one more where we have a rectangle. I'll come back to that, don't worry. A rectangle is 5 times longer than it is wide. Its perimeter is 48 meters. Find its dimensions. So we always have to, like we did before, always be careful, like read it through, make a picture, start doing your setting it up with variables and stuff. And more important than anything, well, I guess everything's important, but what are they asking? So always check, are they asking for the length? Are they asking for the width? What if they're asking for the area? They might do that. Like, just always pay attention till the end. It's really easy to get distracted. Well, I'm speaking from personal experience. I get distracted by the end of a lot of things. So it's easy to get distracted, but this school math makes us really focus till the end. And it reminds us that school math is just a tool to help our brain get stronger when we're doing things like mechanicking. Like you got to go till the end. If something's wrong with the car, you got to find out what it was and answer the question, like it's overheating. Well, even if my windshield washer fluid is out, that's not the reason. Like that, I might be like, well, I solved it. The windshield washer fluid is out. But no, so we have to read it. Like this one too. I might have just asked how many kid tickets were sold or something like that, but how many of each type were sold. So here we go. We're going to put adult tickets are going to be A, and children is going to be C. I'm just making up variables to match the thing. Number of adult tickets was 3 times the number sold to children. So I know that adult tickets equals 3 times how much was sold to children. That's super important. We can't do anything without that. And then we know that ticket sales, adult tickets were $5. So total sales is going to be $5 for every adult ticket. and talk this through if it helps you. Like, I try to show all the ways when I'm teaching. I don't expect everyone to do all the ways all the time, right? But talk it through if that helps. The total sales is $2 for the children tickets, $5 for the adults, and it went to 1,700. We have not solved equations with two variables in this class. So this is sort of a teaser for what's to come, the good things to come. So we can't solve this yet. We don't have enough information, but we do because they told us this one important piece of info. So wherever A is at in this equation, wherever A is, I could plug in 3C because A equals 3C. And that's because they told us this, the number of tickets sold to adults was 3 times the number sold to children, which is weird, really, because usually like a couple adults bring a lot of children. It just depends. Maybe it was like an opera, right? Now I've got it because of that one key. That's like the key in those Indiana Jones shows or something. You hit the block and that's the key. It opens it all up. Now we could just do a normal algebra equation. So 5 times 3C plus 2C equals 1,700. And what we line it out here, A was the number of adult tickets. C, that's A, is the number of kid tickets. So I know when I get to that point, these were dollar, 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 but we don't care about that because those all cancel. So we can just say 15C plus 2C equals 1,700. Because if I didn't line it out and make a little key there, an extra key, I might think, is that $100 for each kid ticket? No, because they told us they're each $2. But we can know if we have this here, then we go, oh yeah, okay, 100 kid tickets were sold. And then we remember from the last page, the number of adult tickets was 3 times what the number of kid tickets was. So 3 times 100. That was in the problem. 600 adult tickets were sold. So there we go. That I really like that one because we did do some ticket sales problems before, but not with 2 different variables. Does anyone have a question about that one? Do you follow it okay? Alrighty. Got a thumbs up. Thank you. This one will seem easier after all that. A rectangle, so I draw it. Never be shy to draw. Go for it. 5 times longer than it is wide. Its perimeter is 48 meters. All right, a rectangle has length and width, and it doesn't really matter. Usually you put L for the longer side. So that's what I would say. It doesn't really matter. The answer will come out okay anyway. You'll get the dimensions anyway. All right, the rectangle is 5 times longer than it is wide. So this is our important key for this one. 5 times longer than it is wide. And then the perimeter formula. Perimeter is add up all the sides. You could write 2L plus 2W also. I don't care. I just think of traveling around it. So the perimeter, that's of course important. That's going to be 48 meters. So that's another important piece. So 5 times longer than it is wide means the length is 5 times the width. And now we can go just with length, width, length, width equals 48 meters. And of course, we're going to find W first. I'll pause it a second, give you a minute. I don't know if I recorded the whole thing right here. I had it turned off, so I just put it back on here. We probably only have the lecture tomorrow, probably be less than an hour, because I want to have time so people can do any kind of catching up, making up, asking questions, stuff like that, and reviewing. So, but let's jump into a new gear for the rest of today. Section 4.3 is what is a function? Oh, I just got a really great comment. Thank you, because these kind of comments come up when we're in face-to-face class, but not always on Zoom. Sometimes somebody will be like, oh my gosh, that's not how I solved it at all, but I got the answer. I don't know what you did, Jenny, but did I do it wrong, but I got the same answer? No, you're great. And whatever you might have, there's some kind of religious statement that's like, there's an infinite number of paths to the top of the mountain, something like that. Like there's a lot of ways to go that are not wrong, right? Some math teachers teach their students like, oh, if you don't do it my way, you're wrong. Well, that's silly. That's ridiculous. And people are gonna have lots of different supervisors and situations in their life that do things lots of different ways. So yeah, great. If any of you did those problems differently or faster too, or slower, but you got that answer or you understand it, but in a different way than I explained, that's great. And you always could share with us too, but you don't have to. And like I said, in face-to-face class, it's a little more organic. Like people just they'll be like, let me show this on the board real quick. Or they'll talk about their work, like just like, wait, what are you doing like that? But on Zoom, they act more respectful and quiet sometimes. And like, I don't speak up as much in meetings on Zoom. And it's partly because of the indigenous culture where you're respecting your elders or your superiors for sure. Like I do that too. Like I'm not going to blurt out like I would in New Jersey, interrupt someone. But just remember there's a lot of different ways to do it. So just let me know. Don't ever be like, oh no, I'm totally lost. So function notation, I think we'll just start with this today because it's fun. If I say f of x, it might be new to you. F of x equals 3x minus 7. Find f of 8. So you all already know how to do this kind of algebra with an expression. We did these kind of things in chapter 2, but it's a new looking notation for some people. And so I'll show how to figure this out. You really just substitute 8 into x and for x and get a number answer. But I'm just going to write what I just said, f of x. That means f is a function of the variable x equals blah, 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 right? 3x minus 7. So I say that's what I'm saying out loud or in my head, f of x. It could be g of x. It could be any letter, h of x. It could be a different variable going on, f of z. Could be just different. They could have different names. It's just like people, right? They have different names. They ate something different for lunch. They have different variables and different names, but we treat it all kind of the same way across the board. So how to solve this, showing your work carefully, would look like this. I know some of you have seen this before probably, but f of 8 equals 3 times 8 minus 7. But if you haven't seen it before, it looks scary to people sometimes. So don't be scared. It's easy cheesy. You've done it before. Just looks a little funny. Then I leave him alone, or her, or them. I leave them alone right there and don't write anything else below here. You don't have to color that in though, but I'm just showing you like he's done over here. She, them, they're done. And then I finish over here. 24 minus 7 is 17, isn't it? That's the answer. So it's the same as when we've done these in a table. We've done these just checking solutions. We've done them evaluate for this value of the variable. We've done all that already. It's all the same exact what you've done before. It just looks different. So let's get used to like just a few of these just to get used to what they look like. G of, I'll use a different variable now. G of Z equals 3Z minus 8. Is that like just exactly what I did on the last one? Oh my gosh, sorry. Hold on, I'm gonna change it up. 1/2 Z plus 2. Okay, so what's always gonna match is this with the variable in the expression. Those always are gonna match. So like I was saying, it doesn't matter what name they give it, but that has to match up. If it doesn't, then you could catch me in a mistake. And then let's say find, that would be my fault. If they don't match up, it's because whoever wrote the problem was not paying attention. Find G of 10. Then they might ask another one. Find G of -6. Find G. You can find lots, like we've done before, where you're plugging in values, evaluating for this, evaluate for that, like this. It's very much the same skill, but we're just saying it's a function, and that means that it's special. It's special, like a gifted in a way. It's like that kind of just special, like royalty, because it has some special properties. And I'm just going to wait and talk about the properties tomorrow of functions, the domain and range, and how to tell if it's a function or not. But I just wanted you to get a little practice a couple days before the final of this, if the notation's new for you, because you'll see, oh yeah, it's nothing really different. 1/2 of 10 plus 2. And then I don't write anything else on the left. Sometimes people are like, here, are you multiplying G by 10? What are you doing? Like they'll ask me. They haven't seen it before and it looks like, but it's not. It's different. It's just saying, stop here. We're not going to write it anymore right there. And then we go on down the right side. 5 plus 2 equals 7. And then box up your answer or highlight it. So when you look back at it, or if someone else looked, say you're tutoring someone, they might be blown away by the notation also. But someone might walk up and see your work and be like, what were you doing? You would explain it to them, but you'd really have to explain this wild yellowness there. You could be able to, if you box up your answer, keep it pretty well lined up, then it's easy to see that, okay, when Z was 10, the output was 7. Now when Z is -6, so we go back into the template almost. We could do it like that, see? So just remember, it's like a template. -6. That'll be -3. So if you have a whiteboard or a writable touch screen or something, some people really like to just do these over and over on a whiteboard or something, or take screenshots and save them. But if you already have your template in place, it helps. So we did that one. That one equaled -1. And then we could write it up here too, like this, equals -1. this one equaled 7. And now g of 0. Did anyone send me that yet? Let me look at the chat. I was talking too much, sorry. And so we could substitute in 0 also. So kind of that same idea. I'm gonna just erase those out, keep my template, and throw down 0 and do the arithmetic. So g of 0 equal to 2. It also means if I was going to graph them, here's z. Instead of x and y, we could write g of z and z. So we just found when z is 10, the output is 7. When z is -6, the output's -1. When z is 0, the output is 2. And then we can graph that. So we can use function notation just like when we're making a table of any sort, but with function notation. So that's what that would be like our normal x and y for graphing. And that'll actually make a nice straight line, that one. So we'll plot points tomorrow. We have graph paper posted if you need some. We did graphing like a week and a half ago, but want to practice a few more of these before we go? Let's do it. I'm going to take some from the book so they're authentical. Of course, the ones I make up might be authentic too. Oh yeah, we have some with different things going on. Let's see. Let's do practice ones. A little harder. F of x equals 4x squared plus 2. And you want to find f of 1. Then we'll do h of a equals 1 minus 4a. And then find h of -4. And in the practice problems, sometimes they have you do several. Oh, we should do this one with a fraction too. I think I can fit it here. Let's say we've got g of t equals 5 minus 2t squared, and find g of we're going to do 2 of this one, g of 0 and g of 3/4, just so you get a fraction to practice. You could input fractions, decimals, negatives. We don't go too wild with these. I'll do a couple more on the next page with some absolute value, just so you see that in case I had one in the assignment, I forget. All right, pausing this and go ahead and work on these for a few minutes. I noticed something was happening with, remember, I want to remind you to watch your order of operations. So f of 1 is 4 times 1 squared plus 2. So do your exponents first, then multiply, then simplify. So that one's not so weird, but the second one is weird, a little bit strange, right? I'm going to erase G of T and rewrite it on the next page, but I want to make sure I got the inputs right. Okay. Yes, that's right. So h of negative 4 is 1 minus 4 times negative 4. That is like that's a little bit of a sand trap. Multiply first. It happens to everybody. So negative 4 times negative 4, do that first, and then do the adding. Good job, Valerie. Good job, Tommy. Very nice. Super rocking good times. Now here's G again. G of T was 5 minus 2t squared. So I asked you first to find G of 0. 5 minus 2 times 0 squared. Same thing with that one. See that? We do that exponent first and then the multiply. So it's going to be 5 minus 2 times 0. So that's 5. Tricky, see? Not the math is not like, it's not hard math. It's not hard like brain busting math, but it's these little tricky quicksands that can happen, right? Any questions about that one? I'll do the fraction one next, of course. Let's say we've got G of 3/4, it was 5 minus 2 times 3/4 to the second. I'll do each step. Do the exponent, multiply. That's like 2 over 1 times 9/16. And then common denominator, 5 times 16 is 90. Almost had the room. 72/16. And then reduce. Let's see. 4 goes into them both to something bigger. 18/4. 8 goes into them both. Yep, so it's 9 over 2. Did anybody get that yet? Let me check the chat.
Isn't you took 5 times 16, right? Isn't that
Yeah?
8?
Oh, you're right, Tommy. You caught me in a mistake. 5 points for you. Super. Oh. I didn't do that on purpose, but thank you for catching that. 5 points, and then 80 minus 18 is 62, right? And that would reduce to 31 over 8. They leave those in our book, they leave those as improper fractions in this section, but I don't care if you wrote it as a fixed number. I would just leave it as an improper for a WebAssign. Thank you so much for catching that. Very nice. All right, just 2 with absolute value, because we haven't looked at absolute value in a little while. And then I think that's enough for today. There's 4 and 5. G of u. Absolute value of u plus 2. Find G of -5. And then here's h of s. Some books don't have all these different letters, and it would just always be f of x, f of x, f of x. There we go. Those are the last two for today. Just practicing with function notation, reviewing the order of operations, and that kind of evaluating for a value of the variable, and simplifying tiny bit of fraction review. We just write down who's sending these answers, and then we'll go over these. Two, 2, 4, 6. Right. And again, these are, I would just say, I already did say there, the math is not tricky. You saw the mistake I just did, right? That little mistakes like that is what'll slip us up, catch us up. But if you just, we take our time and do the steps and remember absolute value rules. So -5 is in here where U used to be. And that's going to be -3. Absolute value is +3. So the absolute value of a negative, if it's inside of those goalposts, it's going to always be positive. This one, the next answer is negative because what happened inside the goalposts, it happened. But then more action is going to happen afterwards. So absolute value of 4, subtract 9, the absolute value signs are gone. So we can have a negative answer. Great, you got in right before me, Kristen. Good job. Okay, Carrie, that sounds good. Be safe. We'll be thinking of you. I'll send you good vibes for what it's worth. I'm so impressed with everybody. Sun dancing, taking water samples, appointments. It's a really powerful class. I give you your points, Kristen, and you got it. All right. Any questions about those? Now, a couple people wanted to talk to me about certain problems with their homework